Space and time are related by a certain metric that kind of forces a conservation principle on the two together. If you say that to a physicist who specializes in relativity, the physicist will probably say that the formulation isn't true. But it is almost true. If you have all time, then you have no space, and vice versa. In between that, you have various proportions of space and time that, when manipulated by this metric, that add up to a fixed quantity. It looks like and behaves very much like the extended Pythagorean theorem, where the invariant quantity is the square of the hypotenuse. That is the fact that encompasses space-time. That is why it is treated as one thing instead of two. But how do we visualize such a thing? Well, we realize that it has something to do with motion, and motion has something to do with relative motion. It also has something to do with mass. Consider a square grid with time rising vertically and space flowing horizontally. Then, when there is more space than time, the mass moves a great distance to the right, but a small distance up. When there is more time than space, the mass moves a great distance up, but a small distance to the right. But an object traveling at the speed of light will travel along the horizontal axis only. An object standing still will travel along the vertical axis only. Again, we have described a fact about space-time, but we haven't visualized space-time. And the usual way to picture it is as a rubber sheet that can be deformed by matter. But that doesn't show you how the metric is involved in this.
A metric is simply the method to be used to measure the distance between 2 points in space-time.
So, as long as you are willing to consult the metric when you try to compare distances, this visualization will do fine.